let's move to feedback, remote feedback. So again I will take this linear regulator example. So this is my system which requires let us say this is 1.2 volt and this is drawing 1 amp of the current. Okay. So, and assume this is your chip 1 and this is your chip 2. So, on your board you have a 2 chip module where your regulator is the 1 chip. Okay, it is a off chip regulator not integrated in that system, and you have your system which is integrated into a different chip. Just like we saw the mobile example, you had a PMIC and which is supplying voltage to different other modules, which could be your RF wireless transceiver or your audio amplifiers or your processor. So, just assume that you have a 2 chip module on a board. So, now if this has a local feedback, so your output is here. Okay, so if this is your V out pin, okay, then on board how do you connect? You have a traces running and your feedback is coming, let us say, I mean best you can achieve if you take the feedback from the pin. Okay, and your capacitor is also, let us say, this everything is connected to the pin. Usually that is how you do actually. I mean you try to keep your pass FET as close as possible to the pin of your chip, so that you do not add any parasitic resistance. So, what would happen? You have traces and this trace will have some parasitic resistance. Let us say I call it RT, R trace. So, what will the voltage which will appear at V out? So, your V out is, if I call it, if this guy is V out reg, so V out reg equal to, sorry, V out equal to V out reg minus how much? I load into RT, correct? This is your I load. So, which means more is the load current, your output will drop more, and you have some accuracy requirement here. Okay, so let us say this guy is 10 milliohm. So, 1 amp means 10 millivolt drop in the output, correct? Or it is a 12 millivolt, then you will get roughly how much? 1%, 1.2 12 millivolt. So, 1% error you will get in the output, and 1% is supposed to be huge actually in terms of inaccuracy. So, how can we fix this? What can be increased?
Wires width can be increased.
No, but that will cause something. You will need more space on the board, and you have limited space. You cannot just make your wire as fatter as possible. That's.
Sir, actually take the feedback from.
So you move your feedback point. Ideally, I want to sense the point which I want to regulate. So why do I need a feedback from pin rather than I would like to take the feedback from remote point. Okay. So what you do when you design the regulator, you provide not just V out but feedback pin also, so that it can be connected to the farthest point. So if this is your regulator, if this is your V out, I will provide one more. So instead of connecting this local, you won't connect it here, you will leave it open. So this point will become VFB and will go to a separate pin. So now again do the same thing. You have your system cap and take the feedback from here. This is your remote feedback. So what is happening here? So what will be the voltage? V out, the local voltage at the regulator now? No, that this will be 1.2, I know this V out, and this is your V out reg. Let me make it clear. So what is V out reg now? V out plus, okay, and you know the drop across this trace is I load into RT, so it will get subtracted and you will get V out whatever you desired. Okay. Is there any drawback of this? Benefit, obviously we know that. Sorry? RT is very small, this pole will be at very high frequency, milliohm. Okay, that's a cost factor, one pin. What about efficiency? It will increase or decrease or remain same?
Efficiency will decrease.
Why?
Sir, because this
Power is being dissipated over RT.
But that was happening earlier also. So there are a few things here you need to look into. So when this was regulated at 1.2 volt, this guy was below 1.2 volt. So obviously your system, I mean if this is a, let's say, a switching system, then CV square F losses will be slightly lower because voltage you have reduced. Okay, but here you look at the one more point here. In this case, you are now regulating the V out or local voltage is slightly higher. So the dropout across that FET is now slightly reduced. Okay, so they may compensate. So I mean it all depends actually how much you gain by doing that, and sometimes you may have to underperform your system also, because if let's say you run at the full strength, you want 1.2 volt, but you are supplying only below voltage, then that means you cannot run it at full strength. Okay. So, your system is forced to run at lower supply and lower performance. Okay. So, overall it may not affect efficiency much, okay, if you consider both the cases. In one case you are gaining from your system the efficiency, other case you slightly gain from your dropout voltage. I square R loss is in both the cases, because resistor is there, current is flowing. So, whether you do it or not, it may not matter, your I square R losses will remain there. But if your accuracy is more important, then you do not have any option, you have to do this. Is there any other way I can fix this without putting this feedback? Yeah, you can slightly move the Vref, but you need to know the resistor value, all the drop. So, if you know that your current is fixed and your R is whatever the known, I mean you can calibrate also. Initially you can measure and see if it is coming 1.2 volt or not, whatever is. So, you keep on changing the Vref unless your output becomes the desired whatever you need. So, you may have to calibrate, and you need a very fine regulation, maybe like if depending upon what accuracy requirement. If you want within 1 millivolt, then you have to change your Vref by 1 millivolt step. Okay. So, without changing the feedback you can do that, but then you have to do that for every load current. When the load current changes, then that again drop across that resistor will change, then you have to move that up or down. Okay. So, next one is POL. So, this is more or less related to the previous feedback case, point of load. Anybody has heard this term, point of load? Point of load regulator we call it. And you can easily guess from the definition, point of load, which means you are putting the regulator at the load point actually. So, you may have two cases. One is centralized supply. So, let us say I have system 1, system 2, system 3. So, let us say this guy requires 1.2 volt, 1.5 volt, 1.8 volt. So, you have one regulator which is taking input, let us say 3.6 volt, or yeah, I mean let us better take this, make it them same just to simplify. The other case is also valid, but I want to first start with this simple case. So, 1.2 volt, and you distribute them to these 3 modules. Okay. So, now can we take the remote feedback in this case? Because these are distributed systems, you do not know which one you take. You take from the other one, and other might be at some different location. So, the resistance actually, trace resistance of all 3 will be different, correct? I mean, in the best case, you can have the remote feedback from the path point which has a maximum resistance. So, other will always be higher, they won't be dropped, but the problem is there might be some reliability concern. They may be regulated a higher voltage. So, higher is also a problem, not just a lower voltage. Okay. So, from this, by taking the remote feedback, you can regulate only one point, not all the 3 points. So, most of the time you just have a local feedback and you just distribute like this, and if your current is very high, then all 3 will have a different voltages. So, you have this, I call it, let us say R1, then this is R2, okay. Remote feedback, so what do we do? So, let us say this is 1 amp, this is 1 amp, this has to supply 3 amp. Okay. So, total 1.2 volt and 3 amp. So, each system requires 1 amp. So, 3 amp you require from the regulator. So, you need to design a regulator which can supply 1.2 volt output with 3 ampere current. So, what I do, instead of doing this, I will use 3 different regulators, smaller regulators 1 amp rather than a single big regulator of 3 amp, and I will place all of them closer to the system. So, distributed supply. So, you have a system 1, system 2, system 3, garage 1, so you have 3 regulators. Now, I can place these regulators as close as possible to my system. In the previous case, if you want to place it closer to the system, you can place only closest to one of the 3 systems. Okay. In the best case, if you want to equally distribute, you will put at the maybe middle, so that your R's are equally distributed. But in this case, you try to place them as close as possible, and these size of these regulators will be smaller, because now each regulator is supplying 1 amp instead of 3 amp. So, overall area impact you may not have that much by doing this, and this is always a preferred case for high current systems, especially processors and all those. And the same thing is possible for if you have a, let us say, 3 different supplies. Sometimes what we do actually, we have a single chip and all 3 supplies are integrated in the same chip. You make it centralized and you will distribute. So, rather than doing this, you make a 3 chips of different voltages and put as close as possible to your system. So, this is true for both different supplies as well as if you have a multiple system of the same supply voltage. So, you can do for both the cases.